Hi, in this video I'm going to look at some numerical examples of equations for a straight line. I start with a simple one, which is basically identifying gradient and intercept, and then we will move on to more complicated questions. Right, the first example is quite a simple one. We're given the equation of a graph y is equal to 3x minus 1. Let's write this down here. Y is equal to 3x minus 1. And we are asked to identify the gradient and the y-intercept. Right, if I compare this equation with y is equal to mx plus c, it's obvious. If we take like terms, compare like terms, m is equal to 3 and c is equal to minus 1. That means the gradient is 3 and y-intercept is minus 1. We can quickly examine this by drawing the graph of the line. Now, to draw the graph of a line, you can put an x coordinate in the equation and find a y, and put another x coordinate and find a y, and you connect the 2 points. And because between any two points you can only draw one straight line, that will be your straight line. But it's clever to be a little bit selective about the points. Now, if I have y equals 3x minus 1, let's put x equals to 0. If I put x equals 0, I'll get y equals to minus 1. That means the point 0 minus 1 is on the graph, which will be somewhere down here. If I designate this point as minus 1, so that would be 1 point on the graph. Now the next point I choose is that where along the x-axis where y is 0. If I substitute y is equal to 0 in the above equation, I'll get 3x minus 1 is equal to 0, which gives me x is equal to 1 over 3. That means the point 1 over 3 and 0 is also on the line. So let's say that's that point. So this is 1 over 3. In this case, if I draw a straight line between these 2 points, that should be my line. As you can see, here I'm showing the line in orange. It goes through the point x equals 0 and y equals minus 1, which gives us the y-intercept c. And the gradient is, if I divide run over rise, in this case would be 3. That means if I start from here for a positive movement in the x direction, the ratio of this length over that length would be 3. So to wrap up, this line y equals 3x minus 1 has a gradient of 3 and a y-intercept of minus 1. Next question is asked to find the gradient and the intercept and the y-intercept of the straight line with equation 3x minus 5y plus 6 equals 0. So if I write my equation here, 3x minus 5y plus 6 equals 0. I need to write this in the form y equals mx plus c to find the gradient and the y-intercept. To do this, we just do a little bit of algebra. If I keep minus 5y on the left-hand side, I'd say minus 5y is equal to minus 3x and minus 6. Here I've taken the term 3x and plus 6 to the right-hand side of the equation. Remember, whenever we move terms from one side of the equation to the other side, we change the sign. It's the same as taking away the same quantities from both sides. Now, I have too many minuses here. I don't like that. I multiply both sides by minus 1. So basically, this becomes 5y and that will be equal to 3x. That will be plus 6. Now I divide both sides of the equation by 5. I get y is equal to 3/5 of x plus 6 over 5. So the gradient, in this case m, is equal to 3 over 5. And the y-intercept will be 6 over 5. This would be, if I multiply top and bottom by 2, this would be 0.6. And this would be 1.2 in decimal form. I hope that's clear. So basically what we have done, we've taken the equation, we make y the subject of the equation, and once we do that, the coefficient of x is our gradient, and the free term, which is our c, which is our y-intercept. It is a good time now to introduce another method of writing the equation for a straight line when we have the gradient and when we know a point, like in this case 3, 1, when we know a point that the line goes through. I will first derive the equation so that you know how you can derive it if you need to. If I start with the standard form of the equation, which is y equals mx plus c, assuming we have a point A with coordinates x of A and y of A that lies on this line, that means this x and that y fits that equation. It satisfies this equation. So I can write y sub A is equal to m times x sub A plus c. From here, we can write c is equal to y sub A minus m times x sub A. Now, if I substitute this c into our original equation y equals mx plus c, that equation becomes y is equal to mx plus y of A minus m times x sub A. If I rearrange, I'll write y minus y of A is equal to, and I will factorize an m between these two terms, m times x minus x of A. So we get this expression for the equation of a straight line where we know the coordinates of a point that the line passes through. And this will help us find C directly. To apply this in the case that we have, We know that our line goes through the point with coordinates 3 and 1. The point P has got coordinates 3 and 1. So our equation for the straight line will be y minus 1 is equal to 2, which is our gradient given, times x minus 3. This will become y minus 1 is equal to 2x minus 6, which reduces to y is equal to 2x minus 5, which is the same as we found earlier. You can only use this expression when we have the gradient of the line and we know that the line passes through a point. This is a slightly harder question. We are asked to find the equation of a straight line that is parallel to the line 4x minus 2y minus 6 equals 0, plus 6 equals 0, which goes through the point P with coordinates 2 and minus 3. Right. What we need to do, we want the equation of a line that passes through this point, then its gradient is the gradient of this line up here. Our first step is to find the equation of this straight line in the form y equals mx plus c, so that we can find the gradient. So my equation is 4x minus 2y plus 6 is 0. So I will make y the subject of this formula. So I'll write 2y is equal to minus 4x. That 4 doesn't look very good. And minus 6. So we have all these minus signs. We can cancel them by multiplying both sides by minus 1. I get 2y is equal to 4x plus 6. And if I divide by 2, I'll get y is equal to 2x plus 3. So the gradient of my line is 2, and the intercept is 3, somewhere up here. So what we need now is to write an equation of a line that passes through this point P with coordinates 2 and minus 3 and has got a gradient of 2. Now, in the previous section, we did exactly this exercise. So the equation would be y minus 3. I think I'd better refresh our memory for the formula. The formula is y minus ya is equal to m times x minus xa, where a is some point that the coordinates of which we have. So here ya is minus 3. So I write y minus 3 is equal to, the gradient is 2 times x minus 2. This will give me y plus 3 is equal to 2x minus 4, which gives me y is equal to 2x minus 7. So this is the equation of the line that we're looking for. As you can see in this diagram that I've sketched, this is our line, first line, which is 4x minus 2y plus 6. Now when we wrote it in terms of y equals 2x plus 3, this has a gradient of 2, i.e. rise divided by run is 2 here, or the tan of this angle is 2 for those who've done trigonometry. And here the intercept will be 3 at that point. I haven't marked, but this line is parallel to that line, so the gradient is 2 and is passing through the point 2 minus 3. The equation of this line is y equals 2x minus 7. And if we extend this y-axis and where it makes, when it crosses the line, that would be our y-intercept, which is minus 7. In this section, we are given a more difficult problem. It says find the equation of a line passing through the points A and B, and we are given the coordinates of A and B, and we are asked to write the equation both in the form of y equals mx plus c or in the form ax plus by plus c is equal to 0. Forgot to put that there. Okay. Now, the first thing we need to do is to find the gradient of this line. The gradient of this line is given by this, the ratio of these two lengths, which is rise over run. Now, if you notice, if I mark this point as O, OB is equal to the difference between the y coordinates of B and A. It's YB minus y of A. And OA is the difference between the x coordinates, the x of B minus x of A. So the gradient of this line is given by OB divided by OA, which will be YB minus YA divided by XB minus X. You must always be careful when you try to work out the gradient. If you start with YB minus YA, the denominator must also be XB minus XA, i.e. you have to be consistent with how you choose your points, the first point and the second point. If I could have written this as y of A minus y of B, but then I would have to have x of A minus x of B. It would be just the same as we have multiplied both tops and bottoms by a -1. So in our case, M, if I take point B as my first point, B has coordinates. I better write the coordinates of B is what? B is 4, 19. B is 4 and 19. And A is -3 and 5. So the gradient would be YB minus YA, which is 19 minus 5. And the denominator would be XB minus X of A would be 4 minus -3, which gives us M would be 14 divided by 7, which is equal to 2. So the gradient of our line is 2. Now we will push this up a bit. So I basically have to write an equation for a line with gradient 2, which passes through either A or B. It doesn't matter. We could choose one of them. I'll choose A. So this would be y minus y of A, which is 5, is equal to gradient times x minus x of A, which is minus 3. So this would be y minus 5 is equal to 2 times x plus 3. This becomes 2x plus 6. And y then would be 2x minus 5 comes to the other side. Well, let's write it plus 6, and that becomes plus 5. So y will be equal to 2x plus 11. I'll write it up here. Y is equal to 2x plus 11. Now, if we want it in the form of ax plus by minus plus c is equal to 0, we'll take everything to the left-hand side. I'll get minus 2x plus y minus 11 equals to 0. So our equation is y is equal to 2x plus 11, or minus 2x plus y minus 11 is equal to 0. I'll see you in the next video.